Hello everyone, welcome to Programming Knowledge. So I again welcome you all to yet another tutorial at Programming Knowledge. So I welcome you all to Programming Knowledge. So let's get started with today's tutorial. So the title of today's tutorial is House Robber or Maximum Possible Stolen Value from Houses. So this is a dynamic programming approach. So we are going to solve this problem using dynamic programming. So we are going to solve this using dynamic programming. The DP we are going to use, and this is a very interesting problem. Dynamic programming I'm going to use here. So what we are going to use, like here, let's see. I'm going to use dynamic programming here, and what you can do. So in short, I will say DP. So there are n houses built in a line. So before I get to the problem, first I will dictate the problem to you, and I will tell you how you can approach this problem using dynamic programming and how you can solve this. So the title is House Robber or Maximum Possible Stolen Value from Houses. So here you can say n houses or array of houses. So sorry, array of house values. So you will get either n houses or an array of house values. So both of them mean the same thing. So I'll explain this problem. No issue. There are n houses built in a line, each of which contains some value in it. So there are n houses, and each of it contains some value in it. Like this is a value, this is a value, this is a value, this is a value, and I have n houses, and each of them has a value in it. Now a thief is going to steal the maximum value of these houses. Yeah, but he can't steal in two adjacent houses. So he can't steal in two adjacent houses. The reason being, it either like this is a house, the adjacent to the left is this one, and adjacent to the right is this one. Like 3 and 8 is one adjacent house, a pair of an adjacent houses, and 3 and 1 is again another pair. So 3 and 1 and 3 and 8. So these both are and adjacent houses, a pair of adjacent houses, and because the owner of stolen houses will tell his two neighbors left and right side. Like suppose like the thief wants to steal a maximum value, just at any instance, I'm talking about any instance, it steals the value 8. So it cannot either steal the value to its left, 8 or 3, or 8 or 2, because the owner will tell its neighbor that there has been robbery in his or her house, and to protect the neighbors, he will warn others neighbors, so the thief cannot steal the value in the neighboring houses as well. So what is the maximum stolen value? So like I said, the thief cannot steal the value to the adjacent houses. It cannot steal the value to the adjacent houses. Like if it steals the value 6, then it cannot steal the value next steal the value 7, as it is an adjacent house. So you need to remember, he can't steal in two adjacent houses. Yeah, this is the main point. He can't steal in two adjacent houses, and because the owner of the stolen houses will tell his two neighbors left and right side what is the maximum stolen value. So we will solve this program using dynamic programming, and let's I have my file here. So let's start with the program, and first just for the test case simplicity, I'll type here print house robber, and I can save this file and I can run this using build function, and here you can see the output of this print house robber. Okay, so let's solve this program using dynamic programming. So what you can do, you can solve this using dynamic programming, and it's very easy. And I'll also explain the both time complexity and space complexity of this solution using dynamic programming. So let's first copy the test cases here, or either you can copy let's copy the test cases here, and then we can this is the first test case, and this is the second test case. So I'll also explain both the test cases. So first let's make our program, then I will explain the test case. uh, like see, you have an array. First I'll explain in short. You have house values 6, 7, 1, 3, 8, 2, 4. Since we cannot steal the value in two adjacent houses, so what is the maximum value the robber can steal? Since he cannot steal in two adjacent houses, this is the main. So for the optimal solution is 19. How come is 19? First he will steal in 6, then he cannot steal in adjacent, so he has to leave one house. He will steal in one. He cannot steal in adjacent, so he will steal in 8. He cannot steal now in adjacent, so he has to leave this and he will steal in 4. So 6184 is one possible solution. Next, he will steal 5. He cannot steal in adjacent, so not 3. So he will not steal 4, but instead steal 11. Yeah, here you can see he stole the value 5. Good. He cannot now steal 3. He cannot, because he cannot steal an adjacent house, but he can steal 4. If he choose to steal 4, I'll give you a very good example here. See, if he steals 5, he cannot steal 3, but he can steal 4. Okay, but if he steals 4, then he cannot steal 11 in the next, because that is adjacent. He can only steal 2. So for that, what he does, 5 4 2 is equal to 11. Instead of what he does, he steals 5. He cannot steal 3. Then he had a chance to steal 4. Even he also misses it, but steals to 11, because 5 and 11 will give the answer 16. So this is the optimal solution for this problem. But how did he achieve this? You can do this using dynamic programming. So let's do first test case and a second test case, and we will solve for both the test cases. So let's copy this, and yeah, sorry. So let's copy this. This is the first test case and this is the second test case. And now let's get the second test case. Yeah. So the output for the first one, output for this is 19, and output for this is 16. And I have told you the optimal solution, that he is going to store 5 and 11, and for this he is going to steal 6 6184 6 1 8 and 4. So this is the output. So let's solve this problem. Define solve function, solve dp, and for this what I'm going to have, an array a, and its choice if you want to give n. If n is equal to 1, then return a of 0, because you have only one element to steal. So you have only one element to steal, so you only steal that. If we have only one value to steal, okay, if we have only one value to steal, if we have only two value to steal, then select max of either 2. Perfectly fine, max of either 2. So if we have only one value to steal, then we only take it. If we have only two values to steal, then max of either 2. If n is equal to 2, then return max of a. Else use dynamic dp to compute optimal solution. So above two were the base cases, else use dp to compute optimal solution. So how we are going to compute this? See, now a of 1 is equal to max of a of 0 comma a of 1, because I'll explain this, because you want to start with a max value. So you start with either first house, you steal the first house, or second house. So I said, like you want to like I said, you want to start with the max value, so you steal the first house or second house. Okay, so this is the base case. And so you like he can't steal into adjacent houses. This is the key point to note. So what we are going to do, So what we are going to do, for I in range 2 to n, simply for I in range 2 to n, a of I is equal to max of a of I minus 1, comma a of I plus a of I minus 2. Then we return a of minus 1, the last value. Okay, I'll explain this quickly. The first is return the last value, since it is it is it is a sum of all maximum possible stolen values. Return the last value, since it is the sum of all maximum possible stolen values. And now we are going to compute, else use dp to compute optimal solution. You want to start with the max value, so you steal the first house or second house in starting. So that's pretty clear to you. So okay, I'll remove this. Just so you steal the first house or second house, and I'll explain this for loop. You have a choice. You have a choice, either either take the either take the max current value, because I told you you cannot steal two adjacent houses. So like I explained the case here, like either you take, you since you need to, if you take one house, then you cannot store the adjacent values. So this is the case, I'll write. This is the case to like you have a choice, like since you cannot steal in two adjacent houses, so you have a choice to steal in the current house, or steal in the current house and steal either to steal in the current house, or or you steal in the current house and house one house apart from it. So either you steal, like you have a choice to steal in the current house, either you steal in the current house, or you steal in the current house and one house apart from it. Okay, so I'll explain this more efficiently. Like you see, a of I is a max of a of I minus 1, comma a of I plus a of I minus 2. So like steal in the current house and one house apart from it. So this defines this case, a of I plus a of I minus 2. Else max of a of I minus 2, like to steal in the, either you can see steal in the previous house, steal in the previous house of current house. Okay, uh, current steal, either steal in the previous house or steal in the current house and one house apart from it. Now this sounds perfectly fine. So I'll explain this. You have a choice to steal in the previous house or steal in the current house and one house apart from it. I repeat, either you have a choice, like a of I is equal to max of a of I minus 1, to steal in the previous house or steal in the current house and one house apart from it. Now I will run both the test cases, then print solve dp of first test case and print solve of dp of second test case. So like I have an error here. Okay, so I missed this length first test case, and I send the parameter length second test case. So perfectly fine. I have two answers, 19 and 16. Just to avoid the confusion here, either you steal in the previous house and steal in the current house and one house apart from it. So previous house is a of I minus 1 and the steal in current house is a of I and one house apart from it is a of I minus 2. So this sounds perfect. So I have the solution 19 and 16. So thank you guys for watching this tutorial. I'll catch up in the next tutorial. Thank you guys.